6 says plot the circle R equals 6 sine theta. Use the domain 0 to 360. Trace, well, let's plot it first and then I'll read the rest of that. So if we clear out what's there and key in 6 sine theta, and I'm going to change my window just because it took so long to graph that other one. And we graph this. We end up with this circle that's sitting essentially on top of the x-axis. Trace it out, of course, we get 0, 0. We need this far point here, which is about 4.2445 degrees. 4.2445, that's 3 spokes. And then you can see the top of this is at 90 degrees, 90 degrees. Now you should see symmetry here, but I'm going to go out over here anyway. So 135, 4.24. So the same distance, 4.24, but now 135. So there's 90, 105, 120, 135. And if you connect with a nice round curve, stay wide, stay wide. Kind of got a little flattened there, but we end up with our circle. Now, trace theta to 300 degrees. So if I trace it to 300 degrees, you'll notice I get negative 5.19, 300 degrees. And this says, draw a sketch to help you explain why the point is in the second quadrant. Notice it's in the second quadrant. Why is this point in the second quadrant, even though 300 degrees is a fourth quadrant angle? And that really has to do with our R and where we're measuring from. So draw a sketch to show you, okay. We ended up with about negative 5.2, 300. This is essentially what it was. So my sketch that's going to show why I ended up in quadrant 2, even though 300 is a fourth quadrant angle, is that I started here at negative 5.2 and rotated 180, 270, essentially 300 to get to here. So we end up with this point where this ray, this red ray, was rotated not a 300 degree angle from here, which will get us in quadrant 4, but because R was actually negative, I started my angle of rotation here and went 300 degrees this way. So quadrant 2, even though fourth quadrant angle.